Hello guys, this is Prime Concept. We want to solve another problem under arrangement of capacitors, right? Now, the question says find the charge on each of the capacitors shown below as well as the potential difference. So we want to find charge on each. Now, first thing you should understand is that these capacitors are arranged in what? In series. Now, when capacitors are arranged in series, what do you need to know about them? When you arrange capacitors in series, the charge in each of them is the same. The charge flowing through each of them is what? The same. And they say find the charge on each. So once we're able to find the charge, it means that same charge is flowing through each of them, right? Now, if you want to find the charge because they are the same, the first thing you want to do is to find the total capacitance, to merge these three as one. So since they are in series, our equivalent capacitance, which is this, for series arrangement is the inverse, right? So I'm going to do 1 divided by 3 plus 1 divided by 12 plus 1 divided by 4. So my equivalent is going to be the LCM, which is 12. 3 in 12 is 4. 4 times this is 4 plus 12 is 1. 1 times 1 is 1. 4 in 12 is 3. 3 times 1 is 3. So my equivalent is going to simply be 7, 8. 8 divided by 12. Now, since I have 1 over C equivalent equals 8 divided by 12, it simply means that my C equivalent is going to be the reverse, the inverse, so which is 12 divided by 8. So if you divide this, you would have 1.5 microfarad. So this is our equivalent capacitance, but remember that is not what the question is seeking for. The question says find the charge on each. Now we know that the charge, total charge, is going to be Q, which is C equivalent times V. So that our charge is then going to be 1.5 times 10 to the power minus 6, because it is micro, right? Times our voltage, our potential difference, 16. And then if you punch this, you would get that our answer is 1, okay, 2.4 times 10 to the power minus 5 coulomb. So this is our charge through each of the capacitors, right? And the second part of the question says we should as well get the potential difference. The potential difference in each capacitor now will be different. So what do we do from there? I'm going to rub this. So find the potential difference in each capacitor. Now, still from this formula, you'd recall that V, let's call this V1, V2, V3. So you recall that V1 simply going to be Q, because Q is the same. So I'm going to call it Q divided by C1. So what is my Q now? My Q is 2.4 times 10 to the power minus 5 divided by my this, which is 3 times 10 to the power minus 6. So that my V1 becomes what now? So if I punch this, I'll get 0.8, which is 8 times 10 to the power 6 minus 5 is 1. Then this minus 1. Okay, so I just have 8 volts actually. So that is my V1. Then the next thing I want to get is my V2. So my V2 is simply going to be same thing, Q divided by C2, right? So what is Q? 2.4 times 10 to the power minus 5 divided by my C2, 12 times 10 to the power minus 6. So if I solve this again, I have 2.4 divided by 12. So this will give me 0.2, so 6. So it's going to give me 2 volts. So this is actually 2 volts. Then finally, to get my V3, we have 2 ways now of finding our V3. One of the ways for finding V3, which is easier, is to simply know that V3 is going to be your total voltage V minus V1 plus V2. So with this, you can get your V3, right? Now, your V3 is going to be your total voltage, which is what now? 16 minus, what is V1? 8 plus V2, 2. So if you do this, you would find that V3 is what now? 16 minus 10, which is what now? 6 volts. So our V3 is 6 volts. Now you can still use this method to find it, right? So you can still simply do, you can still get your V3 as Q, which is 2.4 times 10 to the power minus 5 divided by your capacitance, which is 4 times 10 to the power minus 6. So if you divide this 2.4 as 24 divided by 4, you still get 6 volts. So the same result. I believe this concept is very clear. Thanks for watching. If you have watched up till the end, please do well to hit the subscribe button, like so that it can get across to a wider audience, then comment and share with your friends so that they can also benefit. Remember, this is Prime Concept. Thank you.